A new study finds that this supplement can cure aging. How often do you see such science-backed bold claims in your social media feed, either in the form of headlines or influencer videos? It can be confusing because most people aren't taught how to check the science for themselves. That's why today we're taking a look at how to read a scientific paper, from asking the right questions that matter to you to spotting red flags so that you too can decode the hype. Is the premise of this, you're basically sick of seeing health, nutrition influencers spreading some information that's at best inaccurate or exaggerated and at worst just harmful?
That's part of it. That's definitely part of it. Yes. And I don't think the right way to combat that is to like just find an influencer that you think is better. Because somehow nobody's perfect,
Right.
Of course. And if you can yourself like actually look at the study and at least get some basic understanding of it, I think you're like way ahead of like 95% of people.
Yeah, depending on the format as well of the influencer. If it's a podcast that's like 2 hours long, then you're even quicker just looking at the study.
Right. Yeah, even 2-hour podcasts can be totally...
Yeah, we can have a 2-hour podcast because we can teach you how to apply that to subsequent
exactly. Right. So in this podcast, I'm gonna just try to explain some basic ways to read a scientific study that you might hear from some influencers saying like, this new supplement's gonna cure you from like 10 different diseases and it's based on scientific studies. But then if you actually look at those studies, it is like just from like a cell model and there's no human data and it's like totally unclear what is going to happen when it's actually, you actually take it.
Right.
And so I'm trying to decode the hype of the social media influencers. But at the same time, even within the studies, they're not always perfect. Like you can't just take everything in the study at face value and trust that the researchers knew what they were doing and did everything correctly, and the conclusions that they make from the study isn't always what they should have concluded, as we kind of showed that in a previous episode.
Exactly. The issue that I have, that I feel is sort of a limitation of my experience in education, let's say, compared to you, is that when I go to read studies and I see the conclusion, and let's say I read the methodology or something, I might feel like this doesn't make sense, but I feel like I'd be way out of place to dismiss the researchers' conclusions. Mm-hmm. So basically, I look at different studies and see if there's like an overall consensus. But
yeah, I mean, that's definitely something that helps, looking at other studies on a similar topic. But often you can't do that if, it's something new that's being investigated. And I would also say there's no reason why you can't question a study's methods.
Right. I was going to ask, like, are you saying like anybody can just like poke holes at and ask like, I wonder why they did that.
Yeah, for sure. And often there are valid reasons that maybe you just aren't aware of, which is totally fine. But then you learn, and you're like, okay, next time it looks like they're doing this. Let's see, are they really? I think you have the right attitude, though, to just know that you can start to poke holes in it. And yeah, you're going to ask some questions that they're like, oh, of course, we already thought of that. We didn't do it that way because it's obvious to us.
And if one is, let's say, a proponent of a carnivore diet, they're just going to, like, their bias is going to affect them towards...
Yeah. And that's one of the, I guess, interesting issues that the low-carb carnivore people, where they were very good at picking apart all the problems with the vegan studies, like really detailed. But then when they go back and look at studies that are positive towards the carnivore diet, they're not as careful in their analysis, let's say.
Sure.
Which is, I guess, natural, but...
Yeah, I bet it goes both ways.
Oh, yeah, for sure. Yeah, definitely. So I'm trying to focus on, like, methodology, statistics that both sides should be, trying to make better.
Yes, this is for every person who's interested to be able to advance their understanding of
any studies. And I'm going to focus on health and nutrition, but sure, this kind of thinking can be applied to, studies in other topics like, I don't know, psychology, things like that. I'm just less knowledgeable about that sort of thing.
Okay.
All right. So as we have kind of talked about a bit, we definitely know that health and nutrition research is not easy. There's a lot of issues with it. Like, no study's perfect. It's hard getting enough people in the study. That costs a lot of money. There's always some confounders, like other variables that might influence the outcome. And some studies are just plain poorly written or funded to, promote one outcome for their product, for example.
Right.
I just want to, just say again that, you can have like news headlines and influencers that they'll just take a headline and turn it into clickbait. And you can't just take that as, okay, that's the truth. I think you have to learn a little bit about how a study is usually designed and some basic statistics, but not too much. Like, don't worry, we're not going to go into like detailed math.
Okay.
And then there's some just common pitfalls that many studies and how studies are reported that I'll talk about at the end. The plan of my presentation is to kind of go through how a study is set up. Like, first, you just talk about what's the research question, what topic is the study trying to answer, like trying to investigate, what's the main question, and how are they going to answer it. And then who's in the study, who's being studied in the population. So is it people, is it animals, is it just cells? Then how is the study designed? Like, how many people are in it? Is it a randomized controlled trial? Is there a control? Like, is it just following people over time? Things like that. The fourth thing is just how the study is structured as a document. So just looking at the different sections and where to find things, because most studies actually are laid out in almost the same way.
Okay.
And once you know that, you can quickly go and find the information you're looking for. And that really is good to know. I'll also talk a bit about how results are reported. So how do they answer that research question in the beginning? And then there's usually a discussion section, and that's kind of how they interpret the results. Like, what does it mean overall? What does it mean in a clinical setting? Like, for a person, should they adopt this behavior or not? Is it healthy or not? Things like that. And the seventh section is talking about controlling for other factors, because that's often, you often hear that as something in, you're reading an article about the study, and you often see like the authors controlled for age or sex or things like that. Since that's so common, I just want to quickly go through what that means and how they do it, so it doesn't sound like magic.
Right.
And then the last section is that just the pitfalls, like how the studies or how the influencers and media will often, exaggerate or mischaracterize the studies. I do have a study to like go through as an example.
Oh, okay.
Do you think that would be a good idea?
Yeah, for sure.
Yeah. Okay. All right. So at the end of every section here, I'll be referring to one specific study just to like look at a study and see, okay, let's look at a real study and go through, if we're looking at the research question, where is that in the study? And I'll just show that in the actual study.
Like apply the knowledge that we gained in each section to an actual real life example. Exactly.
Yeah. All right. Let's go for the research question. So this is a pretty, I think, straightforward section. This is basically how the study begins. Like, what are the authors interested in investigating, and how are they going to answer the question that they have? So this research question should kind of describe the main goal, and it will drive how the study is designed and how the statistical analysis is done and how many people or subjects are in the study as much as possible. And it should also include a metric that they're going to use to, for example, either answer the question or analyze the outcome as they want to. Often this should state like a primary outcome. So is basically the main outcome that the study is using to answer the question that they have. And it should be clearly stated and clearly described in the study, unless it's an exploratory study where they're just looking at the data and describing the data. That's fine too. But then they should say it, of course. And there are often secondary outcomes, which are other measures that they'll report on, but the study isn't specifically created to answer those questions, meaning that it's not calculated beforehand. Do we have enough people that will allow us to detect whatever effect we want based on how much of an effect we think there's going to be, things like that.
Okay. Just to translate this sort of. So that's the difference between saying we're going to measure if melatonin increased sleep duration by hours, let's say, versus let's give a bunch of people melatonin and see what happens. We're measuring like 10 different things.
Yeah. And both could be valid.
Right.
But you have to state that beforehand.
Right. You can't do an exploratory and then find out that people's mood was better the next day and then conclude that melatonin definitely improves people's moods.
Yeah. Or causes, or, if you say something like that, yeah, you're definitely overstepping. Yeah.
So that's when you would say further research is needed?
Yes, but they
always say that.
They almost always say that.
That's annoying.
It is a bit. Yeah, I know.
Is there ever like, we're good, this settles it?
I can't think of any specific study that said that in the nutrition and health sciences.
Okay.
Possibly the only one that I could think of is like a smoking study that was like, this is enough data. You don't need to do more analysis. Smoking is bad.
The smoking,
something like that.
The cigarette company CEOs in the 90s didn't quite have the full picture, but now we do.
Right. Yeah. Right. So this one example here is just not the one I'm going to show an actual study, but this is an example of like a research question that shows, okay, we tested the hypothesis that long-term supplementation with omega-3 fatty acids would reduce cardiovascular events in this population. So that's saying their hypothesis is that omega-3 might reduce heart attacks, right, or strokes, I think could be termed a cardiovascular event in whatever population that was.
Okay.
And that's the kind of, they usually sometimes have a bit difficult language to understand, but often it's written a couple times and you can figure it out. Like, I also should mention that after every section, I'll have some questions to ask, which will kind of make it easier to, go through the section and say, okay, what do I need to know? What do I need to ask about in this section applied to the study? So,
wait, are you asking it to me?
No, I mean, just in general.
Okay.
I'm not saying like you should.
You're going to quiz me or something.
No. Okay. So these are just some questions that one should ask when you're looking at a study and trying to determine the research question. So what is the main single question the study is trying to answer? Is the primary outcome clearly stated? And is it the right one for that question, to answer that question? Are the secondary outcomes also labeled as exploratory, or are they trying to like sell that as like the main thing? If the main outcome doesn't work out like they hope it to, are they just going to choose a secondary outcome and make that the main conclusion? And the last question is, does that question matter to you? Okay. Which could be related to how it's promoted in the media. If you see a headline like, this supplement is good for the heart, but what does that mean in terms of the question in the study? That could mean something like it just reduced LDL cholesterol or something. And okay, that might be good for the heart for sure, but it's like an intermediate thing that saying is it good for the heart, not very precise, I'm saying.
So you're not saying that if somebody doesn't care about heart health, they should just move on from the study?
No, I'm just saying you should know what that means in terms of what was the actual metric they're basing that claim on.
Because if they say it's good for the heart, then nobody's going to say the heart doesn't matter to me.
Right, of course. It matters, but in what way is it good? All right. So this is the study we're going to use to apply our...
roast?
No, well, maybe. We'll see. But as you can see, it's a study, it's a randomized controlled trial looking at cardiometabolic effects of omnivorous versus vegan diet in identical twins.
Okay, interesting.
Okay, it is interesting. We'll talk about that more later, but first, I want to just find what's the primary outcome, like what's the main question they're trying to ask. And I've kind of highlighted some stuff. And this study actually does make it very clear. So you can see the abstract and you can see clearly the objective that they want to investigate. So they want to compare the effects of a healthy vegan versus healthy omnivorous diet on cardiometabolic measures during an 8-week intervention. And they say specifically, the question is, what are the metabolic effects of a healthy plant-based vegan versus a healthy omnivorous diet among identical twins during an 8-week intervention? Okay.
Quick question. Are the terms in bold, like question, findings, meaning, objective, design, blah, 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 like universal terms that are, I'm not going to say always, but very, very often used on studies?
I will say often.
Okay. Is the question often omitted?
It's not always clearly listed like they have it here.
Okay, I see.
It's sometimes stated like in the introduction.
Gotcha.
In a separate paragraph.
Yep.
So one good thing about this study is they laid it out pretty clearly in the document, so what the question was. Level 1. Yeah, but a good one.
Okay.
So we also want to find the metric that they're going to base this analysis on. And that right here, main outcomes and measures, you can see clearly the primary outcome was difference in low density lipoprotein cholesterol concentration from baseline to endpoint. So basically they measure LDL cholesterol at the beginning and then 8 weeks later, same measurement.
Okay.
And that's the main outcome.
I think a lot of people also are intimidated by this language.
Mm-hmm.
But if you think about it for 5 seconds, it kind of figure out what they mean.
I totally get that. Like I remember first starting out reading studies, and I'm like, what do these words mean? They're
right.
It's just so difficult. But there is a specific language that once you get into reading more studies, you get used to. And one good thing about the current AI, like ChatGPT,
right,
you can put this paragraph into there and
it will translate to human.
Yeah, more easy to understand language. I wouldn't use it to totally analyze a whole study. It's not always great on that, but it can miss a lot of things.
But to translate sentences that you're struggling with the scientific terms, then it's
really specific ones. Yeah. All right, so I think that it's pretty obvious for this study what the main question is and how they're going to answer it.
Yep.
And then they do say, okay, they have other secondary outcomes like glucose, insulin levels, B12 level, body weight, things like that. So it's nice that they clearly state those are secondary.
Right. If somebody doesn't have a statistical background, they might ask why it matters what metric is secondary and what is primary. Mm-hmm. And I know we've discussed this before, and it can be quite complicated, but there are statistical reasons why you should pick a primary metric before the experiment begins. Yeah. Just wanted to have that out there.
Yeah, that's good. Very good to note. We'll actually talk about that.
Okay.
In a later section. All right, so let's go back to... Okay. The next section is study population. So who's being studied or what's being studied. And it really matters, of course. It's kind of obvious, but just to be clear, even if it's done on other humans, that doesn't necessarily mean it applies to you.
Right.
It could be done on some very unique set of people that have no relevance to your current situation.
Right.
And this is often a problem because in studies, it's easier to, for example, it's easier to recruit college age students.
Right.
Because most studies probably are made at universities. You got young college students there who want to, I don't know, make $50 to like fill out a survey or whatever.
Right.
And the problem is, are they representative of a 50-year-old? In some things, maybe, but a lot of things, no.
Yeah.
And in the terminology that's used in studies, if you see in vivo, that just means in a living organism. So that could be animal or human. And if you see in vitro, that just means within a cell. I just am mentioning that because you'll often see this study was done in vitro.
Are they ever studying dead humans?
Yes, actually. Yes.
What do they say then?
That's good. In non vivo. I don't know. Maybe. Actually, I'm not sure if there's a separate terminology for that. I don't know.
Okay.
Good question. Anyway, if there's like a headline and it does say, even if it does say it's in humans, it doesn't always mean it's applicable to you.
Okay. But generally, like my impression is that that's the hierarchy. Like cells mean less than animals, means less than humans.
Correct. Generally, yes.
Okay.
And sometimes that's the problem. Sometimes with these kinds of studies, it's impossible to study what you want in humans, or very unethical.
Yeah. Well,
yeah.
Do you have like a ratio of if, let's say, this supplement improved heart health for like 10,000 different animals, but didn't for like 6 humans? Would you take it?
I don't know. I'd probably want to. It would depend. I think it would depend.
Okay.
I would say I would probably not take it, but I don't think I would take it, but I would definitely keep an eye on it.
Okay.
I want more studies in humans.
Okay.
I can never.
Okay, to the learnable from that, I guess, is that human studies is where it's at, pretty much.
If possible, generally, yes.
Okay.
Yeah, for sure. Yeah. Yeah, and so that's the section. And basically, the questions you ask are just who or what was actually studied, why did the researchers pick that population, and how similar is that to you? Is it relevant? It's a pretty straightforward question, but there are so many, TikToks, videos, YouTube shorts, where they'll be like, new study, it says that this supplement is the best thing for your health. And then you'll see in all the studies are like cell models.
Yeah, I don't think I've ever seen those videos mention what was being studied, like the population.
Yeah, very, very often not. Yeah. Okay, so I think for the study we were looking at, it's pretty clear who the population is.
Yeah.
Identical twins. And you can see there are 22 pairs, so 44 total. And that is the population. If you want to get more detailed on like their age, so you can look at how many.
There's like a distribution.
Right. How many are female? How many are male? What's the age on average? So it's about 40 for both groups, the vegan and the omnivorous. Of course, because they're twins and they, divided them.
They didn't randomize the...
They did by twin pair, but not...
Yeah.
you know what I mean?
it would kind of be meaningless if they...
Yeah, it would. Yeah. Right. So there's the population. That's easy to find. Usually when you look at any study, that is pretty easy to find.
Mm-hmm.
It's just not easy in the headlines and the
Of course.
videos.
For all intents and purposes, 44 is not that big of a study.
Generally, 44 total is on the low side. Yeah.
Okay.
However, there are, there's clearly reasons that there's only
It's not easy to find
pairs of twins who want to do this sort of study, it's usually a time or resource problem that prevents studies from being bigger.
Makes sense.
Okay, this is now the next section on study design, and this is a bigger section and I would say more consequential. And the basic point here is that how a study is designed determines what the study can claim as a conclusion. So I'm going to just list out some general study type designs and what they can claim, and this will become clear once we look at it. So the overall category of the first main type of study is observational, and those are just usually like you follow a group of people over time and you don't intervene in them. It's not an experiment, it's not a trial. You just follow them over time, and maybe you'll see that one group does this thing and another group does that thing, and how does that affect another outcome? Something like that.
Okay.
And those are usually the larger population-based type studies. You can have, I don't know, studying, there's large databases of health statistics, and you can look at those and kind of follow people over the years and see how metrics change and see how that affects outcomes and things like that. But the main point is you're not changing anything. You're not intervening in their behavior or like giving them a drug or a supplement. It's just following people.
Okay. I'm just thinking, for example, they followed people for 10 years, like a very large number of people, and then over those 10 years, those people recorded whether or not they were eating vegetarian or not. And then they measured the average plaque or whatever. Like, they didn't tell them to eat vegetarian or tell them to eat not vegetarian. They just took these groups and then took the variable that they're interested in and compared them.
Yeah.
Okay.
That's the right idea. Mm-hmm. Yeah, and that's how you usually get those like large diet studies. Like, is the Mediterranean diet better than,
right,
I don't know, just a basic vegetarian or vegan diet? You can, of course, do that in a randomized controlled trial, but it can be much more difficult.
Gotcha.
Which brings us to interventional type designs, which RCT is randomized controlled trial, or a pre-post where you kind of intervene, but you don't have a control group. You just kind of change something in one group of people over the study. It's just an RCT, but like you don't have the control group. You just change that one group, And these are much better at removing any confounders, so any variables that you're not aware of that might affect the outcome. because they're randomized, and the randomization of the people to both groups should cancel any confounders out if you have enough people, of course, which isn't always possible, but it does help. And in this kind of study, it can test causality. So does giving people a supplement cause lower LDL or something, something like that? Whereas the observational studies, generally, you can't test causality, generally.
Okay.
I will say, like 99% of the time, you can't test causality. There are advanced methods, but I don't want to get into that.
Okay. Future episode.
Maybe, yeah.
But to build on the previous example, I want to actually steal your example. Let's say Mediterranean diet. So they looked at, let's say, 10,000 Spanish people and then compared them to 10,000 Americans over the span of 10 years. And just assuming that more people here eat Mediterranean, they could publish a study that says Mediterranean diet helps with this or that. But to establish a causal link, you go to the interventional design, which means you take, let's say, 60 people and randomize them and say this random 30 people are going to eat Mediterranean diet for the next 10 years. And the other 30 are not. And then measure that. And that should establish a causal link. Because in the first example, it could be a number of things that those Spanish people are experiencing that the Americans are not, and vice versa. Definitely.
Yeah.
Okay.
That's a good a good summary of that. Yeah. Yeah. And you can imagine the problems with making people eat this diet for 10 years that's not going to be done.
No.
Really. Be nice though.
In an ideal world.
Just not for the people in the study. Well, it depends on which diet they got. But. Okay, the last one is just kind of an evidence synthesis category, which is just putting studies together and making a statistical analysis.
Okay.
Combining all the data from each study.
I like those.
And that usually gets you a much stronger result if it's done right, of course.
Okay.
And those can be of the interventional type, so it can be a meta-analysis of many randomized controlled trials or meta-analysis of many observational studies. They generally should be similar to each other. Sometimes they have like a full meta-analysis where they combine observational in one section and interventional studies in another section, and they kind of like combine all the evidence together in one large study and see if it all points the same direction or not. That can be nice. So yeah, those are like in the evidence hierarchy, those are considered like the
highest,
the top. Yeah.
Do you know another reason I like the evidence synthesis? As I mentioned earlier, sometimes when I look at a study, I'm thinking, why did they do that? And then I'm thinking, oh, it's not my place to. Like there was probably a good reason for them to do that. But when I'm reading meta-analyses, sometimes I've noticed they go like, well, there were these 30 studies that we looked at, but 5 of them had this flaw, and then we discarded them. And I'm like, oh, good. Looks like they knew what they were doing.
Yes. They will often criticize studies and not include studies in meta-analyses. But again, there are some meta-analyses that I've read that just don't make any sense why they excluded some studies and included some. And like I read one recent one that was on saturated fat, and I think it was just saturated fat, and if it increases LDL. No, it was saturated fat, and if it increases the risk of heart attack. So how many does it increase heart attacks? And for some reason, they only found 9 studies. It was on randomized controlled trials. Only 9 studies total, and like 4 of them were from the 60s, like 1960s. And they were like, and I knew some of the studies because I had looked at them before, and they were like totally weird. Like they had both groups, or one group, one of the diets was like margarine, like it had a lot of trans fats in it. And that was in the saturated fat group, or it was in the non-saturated fat group, and it just totally, you can't say anything about that. And
you can do a lot just by excluding the right studies.
Yeah, you can, but then they'd be left with like 2, so well, I don't know. Anyway, meta-analyses are usually better, but not always, is what I'm saying.
Okay.
All right. So this is just list of other specific study designs. I don't want to go through each one, but it's just here for future reference if you want.
I like you're not going to have so much text on the screen this time.
It's only this slide. The other ones are better.
Marginally.
You should have seen it before I did it.
Okay.
Okay. All right. You did mention before about the number of people in a study and how it's important to set the primary outcome prior so you can calculate how many people you need in it. So this is what we call power of a study.
Is this something that they show on the papers?
Occasionally you will see a quick calculation.
Okay.
But generally you'll just see a statement that's like, this study was powered to find this effect with this amount of people, blah, blah, blah. So power is simply the probability of finding an effect that really exists. So when the effect is real. And commonly we want an 80% power rate. So that means that there's a 20% chance that we'll miss a real effect. And that's called a type 2 error rate in statistics. So there are 4 things that go into that power calculation. It's the effect size, standard deviation, or the variability in the outcome, the sample size, and the alpha, which is usually 0.05, and that is the p-value threshold. And then that power target, which is that 80%. And that 80% is just convention. Sometimes it actually is 90% when you want to be much more careful and you can have more people in the study, like for maybe a drug safety study, something like that. And to also be clear that that p-value is a type 1 error rate. So that's looking at the chance that we falsely claim an effect, like a false positive, and that 1 minus beta, so that's the type 2 error rate, so that's that 20%. So that's would be the chance you miss a real effect or a false negative.
So there's gonna always be some guesswork.
There's always some guesswork, yeah. And of course, these power calculations are generally just for randomized controlled trials, because you're setting up how many people you want in the study to detect something. In the observational studies, the more the better, often is what it is.
I mean, isn't that the case for the randomized control trials as well?
That's a very good question. Often no.
What?
because
we're gonna go into a 30-minute tangent again, aren't we?
yeah, probably. So the main issue there is like cost.
Okay, but
You don't want, if you have unlimited resources and unlimited time, yeah, okay, it wouldn't be bad to have more people, for sure.
okay, that's what I mean. I mean, it's not like you see a study and then another study with like, that's the exact same one, but with more people, and you went like, no, they went too far. That's too many people.
No.
Okay.
I think given unlimited resources, yes, you would just want more people, because why not?
Gotcha.
All your statistics would be more precise, and yeah, for sure. But in the real world, you want enough, but not too many.
Gotcha.
It does state here on the slide, too large, meaning too many people, could detect significant findings, but practically they don't matter. So it would become, that it would be below the p-value threshold, but practically, like, if you had like 1 million people and you're looking at blood pressure, you could find a statistically significant difference in like 1 point of blood pressure difference, which wouldn't matter.
Right.
And that could confuse things, of course, but again, it depends on how you report that.
Right.
That's the only, like, I don't know, caution to that, like, as many people as possible.
Well, makes sense.
Just some rules of thumb, like, for how large studies can be and what we would say is okay or, exploratory or normal. And this is totally, like, not precise.
This is
my general sense. Anything like less than 50, so less than like 100 total people, it's still pretty good. Like, that's a real study.
Yeah.
But could still be kind of a pilot or exploratory study. Like the twin study, 44 people.
That's less.
That's
Way
less. However, the way they set it up increases the statistical power, because they have that like twin thing in there, which really helps, and it doesn't make it like the equivalent of having like hundreds of people,
Right.
but it would be more, I'll say, more robust than like having maybe 60 people, random 60 people.
Is this something that will be shown in the number at the end, or is it something that you go, oh, the numbers are less good, but they use twins, so that's a bonus?
They should analyze it in a way that will reflect that there are twins in the study, and that will lead to like more narrow confidence intervals, so less variation, and generally lower p-values than if they analyzed it in the general way if they weren't twins.
Okay.
At the end of this section, we have some questions to ask when you're looking at a study. Obviously, just what type of study is it in a broad sense? Is it observational, interventional, or that kind of meta-analysis type synthesis? And then that means, can the study design support a causal claim or just an association? That's important, because when you watch videos or read headlines, what you hear will often sound like a causal claim, like this causes that.
Right.
Whereas in the study, it's just an association.
I think as far as headlines and influencers go, they don't make the distinction at all.
No, No, I don't think so. They don't care.
I mean, it's not like I read a lot of studies, but before I took an interest in it, to me, it was just like, this is linked to that. And I just thought, okay, that's
Causal.
something good then, yeah.
Yeah. But linking, association, that's all like some evidence. It's definitely some evidence, but it's definitely below the causal or randomized controlled trial level of evidence.
Yeah.
The question then is like, what if I have like 50 observational studies versus one? I don't know. I mean, that's hard.
Yeah.
That's hard to say. Yeah. It just, then it would depend, I would say. I can't like say a general statement there. Okay. Yeah. So for the meta-analysis, you can look at it and look at if the studies are similar enough. Generally, they should have some way that they determine that in the meta-analysis that where they include or exclude these studies. And then for the power stuff, just some questions about, did they say anything about that? Or basically what I'm looking for here is, why are there this number of people in the study?
Okay.
Give just a reason.
Okay.
You know, it's fine. Of course they need to say how many people are in the study or whatever, but why that many people? And it'd be nice if they clearly state that.
Okay.
So let's just quickly go to our twin study. And can you tell me what study type design is this?
Well, it's a randomized control trial.
Oh yeah, that's all I'm asking for.
Yeah.
So it's an interventional type study. And what kind of claim can that support?
Well, causation of the was it cholesterol? What was it?
Yeah, LDL cholesterol. Yeah, good job. You passed. Was the sample size justified? So they actually do have a separate section on the study design in more detail. Basically, just saying kind of what you already did, but there's a bit more detail that it's a single site, parallel group, dietary intervention, randomized clinical trial, and some more detail about the subjects so that they're healthy adult identical twins. It does say later, here we go, for the power analysis, we aim to recruit 22 pairs of identical twins 18 years or older, a sample size determined by resource availability rather than a formal power calculation. So basically, they couldn't find more twins. They would have liked to.
Or couldn't afford paying them.
Or couldn't afford paying, yeah. So, like, I'm fine with that. As long as it's clearly stated out there.
Okay.
Then we know.
All right. So you would have thought this was maybe, I don't want to say red flag because that sounds harsh, but would it have raised your eyebrow if they just said we have 22 people and didn't explain? We have 22 twins and didn't explain why they got the twin. But then why does that matter?
Because if let's say they didn't find an effect, that they got a null result, that there was no difference between the two groups. If they didn't do a power calculation, I don't know if that's because there weren't enough people in the study, or if it's more likely that it's an actual null result.
Gotcha.
But either way, we want some reason why they have this number of people in there. Yeah. Okay. The next section is very straightforward. It's just the usual structure of the study, how it's documented. So when you're reading it, what sections will you see within the study in general? And once you realize that almost all studies follow this pattern, it's really makes it a lot faster to go through and find what you're looking for.
Mm-hmm.
Because often you don't want to read the whole study. It's just, you know, you might, but like often you just want to know, like, is this study like legit or not? And
I just go to the conclusion.
I would argue that that's not enough. if it's something really important to you.
Yeah. Okay.
You know, like if you're going to spend like $100 a month on some new supplement.
Then I would. Yeah. Okay.
You know, or if there's a potential for some like bad side effect. Like,
then I just send it to you.
Yeah. Right. All right. Yeah. But okay. So, I would say like over 90% of studies follow a similar pattern where you start with the abstract, which is just a quick summary of the study. What are they doing in the study? Who's being studied? And the conclusions, like the results and conclusions. And that can give you like, what's this study going to be about and what results did they find?
I've noticed sometimes the conclusion is in the abstract.
Yeah, often there's like a separate section in the abstract that is conclusion.
Yeah.
I think I've seen that more often in newer studies. Like previously the abstract was just like one paragraph, and now the abstract has become like a half page, like of a quick sentence for like, you know, the intro, the methods, results, conclusion, like as the abstract, which is kind of, that is nice actually. So after the abstract, you just usually have an introduction of like, this usually states again, like the main question they're trying to answer. It'll give some background knowledge, maybe show a short review of the literature that's, you know, previous studies that's been done on this topic.
Okay.
Talk about why it matters, things like that. Then there are methods, which is more detailed about, you know, who or what was studied, how they gathered the data, how they designed the study, what statistical analysis they used to analyze the metrics that they measured. And this, if you really want to get into how good of a study this is, I would say that's the section you want to look at. I like looking at those sections. That methods and results, definitely. Results is just, it should be just clearly the results, like tables.
I do like looking at the results because it's often charts that I can understand.
Yeah. Charts, some nice graphs. They shouldn't, in that results, they shouldn't do too much interpretation of the data of the results. They should just lay it out like these are the results.
Okay.
And then the next section is usually doing that, discussing the results and what do they mean? What's the context in there? Like how strong were they? Is it relevant? Is it clinically relevant? Why did they get those results? You know,
yeah.
Any limitations, any problems with that? And then, of course, end with more research needs to be done. And then the conclusion is clear. It's just the final conclusion of the study. And the last one is just any supplementary material, which can be a lot of data, just like, you know, it's usually like a separate document. If they allow the raw data to be published, it could be raw data, it could be many more tests that they ran. Sometimes you'll find really interesting things in there that should be in the main. Well, I would argue should be in the main study, but sometimes that's where you'll see if there's like a bias of the researchers or the funding and they wanted to promote one aspect, they can kind of bury stuff in the supplements. I've seen that happen. occasionally.
Sometimes I've noticed they say conflict of interest, none were.
Yep.
I've never seen one say that there was, but.
Oh, really? I have seen that, or at least like some sort of funding. Like you will often see funding, like who funded the study, or the author was funded by this organization.
I may have seen that, but I haven't seen like a study that's clearly funded by.
It always takes some more digging, like about that organization. They're not going to be like funded by the organization for promoting vegan diet or something. Like,
right.
Usually.
Right.
Like the keto diet study. Remember the one we did?
Yeah.
That was funded by. What did they call it?
The Fatty 15 was also.
That was a good one. Yeah.
Yeah.
The Fatty 15 was funded by the company that makes the Fatty 15 supplement and is owned by the woman who wrote the study.
But somehow I don't remember it saying in the conflict of interest.
Yeah, I don't remember what it said there.
Because if any paper should have it, it was that one.
Yeah, that would have been nice. But it did say which company funded the study, but then you had to go look at that company to see that, oh, that's the same company that the author owns.
Right.
So, and okay, here's the keto diet, the keto CTA study. That was funded by the Citizen Science Foundation, which sounds
legit.
But I mean, and then you look at that organization and they fund, low carb keto diet studies, which, is fine, I guess. Just
if it's done honestly.
You just need to be aware of it then. So, yeah, I just have some quick questions about this study structure. Does the abstract match what's in the paper? Actually, often the abstract will kind of like overstate or generalize too much of what they actually found in the study. I find that often. And sometimes the methods section is not written in detail enough, so you know what actually happened in this, how they did the experiment. Sometimes they'll just be like, we did this and analyzed the results. Like it's like really not enough detail. Ideally, there should be enough detail in there where you would know like how to recreate the experiment.
Okay. That makes sense.
Ideally, but that might be asking too much, but at least getting there, And then are the results shown clearly with the actual raw numbers, with the effect size, confidence intervals, p-values? Like, do they actually report what they should have reported? Are there any results that are missing, like from the primary outcome, secondary outcome?
I mean, I'm assuming if they omitted something, they would remove it from the...
Yeah. It doesn't always happen. And then the last one is, do the discussion and conclusion stay within the data's limits? So that's basically like, are they overgeneralizing, I guess, too much with the data? If they're clear what they're doing, like, we're just speculating here, it may be this, that's okay, but
right.
Often it's not clear.
More research needed.
Always more research. So I'll just show in the study, we're looking at the main sections here. So obviously it does start with the abstract. And this is one of those full page abstracts where it basically as a summarization of each section.
Okay.
Which is, I think it's nice. And yeah, of course you have the introduction, you have the methods, which has a separate section on study design. I do like that. They're pretty detailed in this. It's very nice. Generally, statistical analysis, how they're going to analyze the data. That's nice. Then they have a section on results, of course, with different sections. Nice schematic about what happened during the study and, you know, how they tried to, you can see like they initially started with 135 people, but it went down to 44.
Why? Does it say why?
Well, it looks like most people were unwilling to travel or schedule problems.
It really gives a lot of info in this case.
Yeah, it's nice. And here, yeah, location, it just says ineligible, so I don't know what they probably had to be healthy, and maybe those people had some health markers that weren't healthy, something like that. And of course, some people just aren't interested. I mean, it gives me confidence in that they're actually being serious about all of the data and making sure they've kept records carefully.
Yeah, they recorded everything. And
yeah, I do like that. See, they have some supplement tables. So let's see, nice charts, secondary outcome section, discussion, main section here, which they talk about interpreting the results, strengths and limitations, which is important. Although I often will see they're not as honest as maybe they should be often with the limitations, like, but that's, you know, at least I want some, I want them to try at least. And then a short conclusion. Yeah. So you did say about conflicts of interest. So here it does list that here. And you can see Dr. Gardner reported receiving funding from Beyond Meat, which is that they make some fake meat products.
Yeah.
And Dr. J.L. Sonnenberg is a Chan Zuckerberg BioHub investigator. I think it is that Zuckerberg. And this study was funded by the Vault Foundation. That foundation basically promotes vegan diets.
Okay. So I didn't see the results of the paper when you were scrolling past it. But now that I see this, I'm inclined to... I'm a bit more dismissive because I'm expecting it to just say the vegan diet was great. Especially because none of them are having interest on the opposite side of things.
Right. They don't have like a guy
Meat
who's
guy or something
from like does
Dr.
work for the
Chaffee.
Beef Foundation. No, not Dr. Chaffee. I totally get that, and it should make you be more careful in how you read the study, I think. However, I don't think it should... I don't think you can just totally dismiss it. I would definitely be more careful of reading the discussion part, and I'd be more careful of making sure they analyze the data properly and reported the results properly. But I have read this study. You want me to like give my take on it now?
No, up to you. If you think it's better to hold off on it.
Yeah, maybe I'll hold off on the specific study, but I will say just like generally when you see something like a study was funded by an organization that clearly is promoting a specific diet, either the study's clearly biased and that's set up, it's set up to prove a point. I have also seen the opposite where they are totally meticulous about how they don't want to come across as being biased. So they will be extra careful in how they set up the study and
Right.
and interpret the results.
Right.
So you can't just dismiss it because it's funded
Sure.
by,
Like if as a good example, I think if it was funded by an anti-smoking organization and said smoking's bad,
right.
I'm not gonna start smoking.
Right.
Just out of spite.
Yeah, exactly. And I would assume that anti-smoking foundation would want like a proper study that is like solid with how they get the data and how they set up the study and analyze the data.
Yeah.
Because you don't want to give the other side, ammunition for like.
Exactly.
Yeah. That's that section.
Maybe just summarize what we looked at today and what we will look at next time.
So we just finished study structure.
Okay, so we looked at the research question, which is basically the question that started an experiment or a study, and the population is how many people or animals or the sample size, basically. And the design is the different types of studies. The structure is the different segments on the paper so that you know where to look to find the information that you're looking for. For example, the results or the conclusion.
And tune in next time when we talk about how results are reported and how we can interpret those results in the studies. So those will be basically the results section of the study and the discussion section of the study. And then the 7th section that we'll talk about is kind of a separate standalone piece that talks about how they control for other factors in studies and what that means, just because that's a very common thing that occurs. And the last section is just kind of the common things that influencers or media or even the studies themselves will do to mislead or exaggerate the findings. And then I will have a final little wrap up with that vegan study that we're talking about, just to close that out.
Is it related to number 8?
Yeah, I will have a couple examples in there about number 8 and for that study. Yeah.